Okay, so I recorded the pipeline tutorial, and those videos are uploaded to this channel, but it's probably a little intimidating to have 4 hours of video to look through. So I'm going to record a new version with just me, and it should be a little cleaner and easier to follow, a little less live troubleshooting, um, and also edit it a little bit to make it shorter, so it should be a little more bite-sized. So we're going to go through the same tutorial or the same document that we did for the real tutorial. So to access that, I'm going to go to the GitHub for the repo, GitHub lcogt sn pipe. And then that tutorial document is now linked here. Whoops, I'm going to open that in a new tab. So yeah, I'm just going to go through this again, but it should be a little easier to follow. So going through the first section, this first section is all about data ingestion. So just to give you an example of how you would normally do it on Snex, normally you'd go to the object page that you care about. So this is the supernova that I just submitted a paper about. So obviously my favorite one. You'd go over to this little tab here that says batch download data. And then this lets you download all the images. The photometries on the left, spectra are on the right. By default, all of our images are selected, so that'd be 343 files. If you want, you can, only select one filter or go through and only select certain images. So you can download whatever subset of the data you want. And then you press the request button, and then Snex will email you links to tarballs and allow you to download all that data for yourself. I've prepared data beforehand, so let's talk about that. Okay, so the installation instructions that you should have followed were these Docker Compose installations. That involves using Docker, which you don't need to understand very deeply for this, but Docker creates a virtual machine. So it's a set of code that's completely cordoned off from the rest of your computer. It's even running its own operating system, technically. So in order to get the data you download to be accessible from inside the Docker container, you have to put it in a specific place. So part of the instructions were setting up this variable, this lcosndir. So all of the data that you want to interact with should live in this directory. So for me, that's this directory. So I have a directory in here, and these are all of these are the 3 tarballs that were included for this tutorial. So I'm going to put these inside my lcosndir directory so that I can access them from the Docker container. Okay, so to boot up the Docker container, I'm going to go to where I cloned the repo, excuse me. And then I'm going to run this docker compose command. So this is part of the instructions. It is similar to this command. The only difference is I'm putting in an ampersand at the end, so that'll run it in the background so it doesn't take over this terminal. And then I look for this line, so this ready for connections. So that means it's all good to go. And then I run this next command, which is just identical to this one, this docker exec command. And so now I'm inside my Docker container. Now, instead of being on my MacBook, now I'm the Supernova user at this randomly named machine, which is the Docker container. So now if I cd into that lcosndir directory, This is the same thing that I can see from my computer, so I'll cd into the tutorial directory. Let me move this so that I can see it better. Excuse me. Okay, so now I have these three tar files for the three targets that are that we'll be reducing. And so there's the script ingest tar, and that'll ingest the tar files and make sure that all the data is accessible in your database. So I'll just go through and do ingest tar -f to specify a file name, and then specify the file name. And so I'll do that for each of the three tar files. Okay, great. So I just ran ingest tar on those three tar files. So just an example of what the successful output for that looks like. So it'll print um, the file names, and then it'll add a new target, and then ingest all of the images into the database. Okay, and I did it for the three tar files. Okay, cool. So the next thing we have to do is run this compare catalogs command. So let me start that going. So you should run this command every time you add a target to your database, or in this case, I'm running it after I added three targets. You should run it before you start reducing data for new targets. So what this does is it automatically goes and gets APAS catalogs, and if objects are in Sloan, it gets their Sloan catalogs, and it also gets their Gaia catalogs. And so these catalogs are used to select field stars for generating the PSF, and also to use those field stars to do 0-point calibration on the images. Okay, so then the last thing we have to do, like the tutorial document explains, is we have to do a little bit of setup, because one of the objects we ingested, L101, is a standard field, and so we have to do a little bit of database manipulation to make sure that that object is recognized as a standard. So the first thing we're going to do is move its file to the right place. So one of the files that was used in this tutorial is this L101 catalog file. So we have to make sure that that's in the right place so that it can get accessed during the reductions. I'm copying that file to LCOS under standard cat Landolt, which is where it should live. And then, like I said, we have to do a little bit of stuff in the database. So to open the database, the command's in the file, but just copying it out. The host, this H stands for host. The host is Supernova DB. The database is Supernova. The user is Supernova, and the password is Supernova. So we're very creative. So just to verify that things got ingested correctly, I'm just going to look at some tables. So there are a lot of tables in the database, but the two ones that we care about are this targets table. So just looking to make sure that my three objects got ingested correctly. And then the other table that we care about is called FOAT LCO. And so that should hold all the images. So that has 39 entries. These are all the images. There are a lot of columns. But yeah, so that's all in there. So that's good. Going back to the targets table, so this last one is the L101 standard field, and so we just have to make sure that this is updated so it knows it's a standard field. So I'm going to update targets, set classification ID equals 1, where ID equals 15, Your ID number will probably be different, but the rest of this command should be the same. Okay, one row affected, good. And then the last thing we have to do is to make sure it knows what its catalog file is called. So that's that thing that we just moved into the standard cat Landalt. It's this L101 Landalt Stetson file. And so again, we have to make sure that the database knows where that is. So just double checking that everything got updated correctly. The classification ID is now 1 for L101. The Landlord catalog is also the correctly named file. Okay, so that's the end of that first part. So this last part you shouldn't have to do too many times unless you're ingesting new standard fields. But the rest of it, making sure tar files are in the right directory and then ingesting them and compare catalogs are the steps you should do whenever you ingest new data or a new target.